I'd go out early and just bring you along for something different. I'm going to hit the bank, the post office, dropping off a few orders, and the dump. See, right now there's the sky. We're looking at stratus, which is lifting up into cumulus. Bases are going to increase from about 1,000 to 1,500 this morning up to about 3,000 later today. Oddly enough, I've got my 10-inch reflector telescope here. I was going to use that the other night to take some video, but I'm going to have to do that a different night, I think. This used to be my house, 2005 to 2008. Some of Digital Atmosphere was written in there. It was built in the late 1890s. I kind of miss that place. And here, this used to be an elementary school back in the 40s and 50s. It's now a hardware store. Which school?
Rusk Elementary.
Rusk Elementary.
Yeah.
Very neat.
Hey, ¿cómo está?
Still limping around, I think.
A little bit, yeah.
Had a knee replacement.
Huh?
Had a knee replacement.
Did you, Kermit?
A hobble too.
Yeah, he's ready.
A little bit.
Man, look at that old flooring.
Hola, ¿cómo estás?
Okay.
Actually, I had to pick up one of these too. I'm going to try to hook that up to my PC because my kid, he's got Grand Theft Auto 5 and wants me to join in, so that's what we'll do. And I think we're done. And another fair day here in Texas, and this is the very first day that I've gone out and my lenses have fogged over from the moisture. The dew points are that high. Sorry, we're starting a little bit late tonight because I had some technical problems with the codecs and the whole video stack, and had to restart the computer. And that happens sometimes. It's just the nature of this video broadcasting. But anyway, let's check out the weather. We do have some interesting weather to show you up in Missouri, but let's start with Texas first. Let's draw that 70-degree isotherm. To draw that 70 isotherm, I got to bring up the tool for that, so let's do that real quick. There we go, got our tool. Okay, so our 70 line is coming up like this, and we've got a 75 line coming into Texas. And that's just the nature of the very high sea surface temperature in the Gulf of Mexico. You remember a few days ago I was showing you low temperatures in nighttime minimums out in the Gulf waters. out in this area, and I was showing you that they only got down to 84 at night. So that's a rich area for evaporation to be taking place, and that's helping to feed a lot of the south central U.S. with that moisture, streaming northward in that southeasterly flow. But then up to the north we have a new front coming in. Maybe it's a little bit more north of there, but it's generating a few showers and storms in the Oklahoma Panhandle and around Dalhart and Perryton. The dry line can't really pick that out. Looks like it might be on the Cap Rock, maybe a little bit further west, but very weak dew point difference across that dry line, so I don't know, that could be more of a trough. Let's go up to the north and look at our front here. This is pretty easy to draw, just looking at the basic wind field. You can pretty well pick that out. And the most important thing here is the moisture impinging on this boundary. So let's draw that 70 isodrosotherm again. It's going to run something like this. And let's see, it goes all the way to Chicago there. Can we do a 73? You can definitely do odd intervals if it helps you. So here's 73. But of course you want to do it in the correct order as much as you can. So we go 70, 73, 76. Do we have 76? Yes, we do. And look at that. We got 77 here at whatever town that is. This is Whiteman Air Force Base. 78. That is some serious moisture there. And of course, as you would expect, that's producing some storms there along that front. This is the water vapor imagery. And you can see by that swept laminar appearance, got a little bit of jet stream energy working through here across the southern Rockies. But let's check out the warnings and watch as we have a severe thunderstorm watch for southeastern Oklahoma, western Missouri, and we're going to pull up GR level 2 and check out those storms. We'll first start with the College DuPage site. Let's make sure this is current. They've got, let's see, 0205, that's correct. Get out of here. So, yeah, this is our big storm here. I guess that's a little bit near northwest of Whiteman Air Force Base. And you can see the outflow boundary. Instead of being out ahead of the storm, like we usually see with gusty, high temperature dew point depression storms, this is actually drawn pretty closely into the updraft. That updraft is right here. I'm just going to show you this in GR level 2, but this is just a quick overview. So definitely some action there. So let's switch over to that. I'm going to have to start the polling on that because I didn't want to mess up the beginning of the live stream. So as you can see down at the bottom, it says downloading. So we'll let it do that. And while it does that, we'll look at a couple of other charts. Let's check out the Atlantic. There's that tropical depression right here just north of Puerto Rico. And that's still on target to go into the Gulf. We still don't know how far west that'll go. And we've got one other tropical storm out there. Where'd that page go? There we go. Gaston, I think. Well, you can see that's pretty far north, so that's probably going to end up recurving or pretty much staying east of the East Coast. To reach the Caribbean and the Gulf of Mexico, we kind of like to see the storms developing a little bit south of 17 north, 1718. And sitting here remembering one storm that went really far south. I can't recall. It was probably about 10 years ago. It went across Venezuela. And then up in here, I'm thinking it might be Gilbert. I don't know. I'll check the chat and just see if anybody has called out a name. And I don't see a storm name that came up. I'll try to look that up if I remember. But it might be interesting to go back and look at these case studies of some of these old storms, and we can check that out. Okay, got our data here. So let's zoom in on that storm. So this is going to be just north of Warrensburg, Missouri. And you remember, one thing I always tell you is that the spectrum width tool is very underutilized. And you can see that kind of confirms the outflow boundary location. It's right there. And that's important because we want to relate that to the updraft. Now, of course, we can't see the updraft on radar because the droplet sizes are too small, but we can kind of infer that it's going to be within this notch area here in this Bear's cage. And sometimes we can see a reflection of that at higher tilts if we go up to 1.8. Okay, so here we're having a problem with different scan times. I don't know if you can see the very top right. Let me bring that down. But you can see I've got the 0.5 at 0208 Zulu, and the higher tilts are older. So you have to be careful with that when you're looking at those higher tilts. Anyway, once we look at those higher tilts, we like to look inside that Bear's cage and see if that gets topped out by an overhang. And do I see that? Yeah, okay, here's a B-weir, bounded weak ecoregion. This is kind of like a donut hole. That's a reflection of the updraft, so we can, if we put together all the other parts of the storm around here and the location of the outflow boundary, we put all that together and we can infer that this is the updraft. And this is the 6.4 degree scan. This is up at 18,000 feet. And as we go higher, that should close off and then be topped by some higher reflectivity. Yeah, you see that. That's the updraft shooting upwards up to about 20 or 30,000 feet and forming very large precipitation particles, and particularly wet hail, which is a huge radar scatterer. And that's what we have right there. This is up at 29,000 feet. Let's zoom in and check that out. 70, let's see, where's the readout here? 63 dBz is right there in the core, 67. Then we go higher, we lose the anvil, and we overshoot the storm. Now we can use the three-dimensional modes of GR level 2, and we'll scan from the downdraft area through the bounded weak ecoregion and then catch some of the overhangs. So let's do that. Okay, I'm going to draw this line out through the B-weir, and we'll check that out. Now, it's possible we're picking up some different scan times, but it looks to me that this here is the B-weir. So you can see it extends up to about 25,000 feet, and what's below it, we can assume that that's the updraft base down here. So this is where you're going to put your spotters down here. They're going to be watching this area for lowerings and rotation. And let's go back and see if that radar time sorted itself out. 208, 28. Yeah, this should all be good. So let me try to grab that one more time, scan right through that. And it looks to me that we are picking up the B-weir right about there. And usually in my experience, definitely from Oklahoma, these very high reflectivity areas suspended over ground which has very little reflectivity, this tends to be a prolific area of lightning, mostly in cloud, but some cloud ground strikes. So it's probably going to be dangerous to be outside underneath this thing. I really don't. When I've chased, I really hate getting out of the car under stuff like this. So, and the last thing we should check out is the velocity. Well, I pulled up the base velocity, and I can already see rotation. See that couplet right here? We have outbound right there and inbound here. So what's the magnitude? I'm seeing ground relative velocities of 40 knots outbound, 13 inbound. So that's not too strong. That's probably about 50 or 60 knots of shear. Let's go to the storm relative velocity and let me set up a movement. I'm going to set this vector here. And this program is a little bit finicky. I've seen the motion vector that it expects be 180 degrees out. So normally what I do is I put where the vector is coming from. So let's go for a movement of 230 at 15. I'll split the difference on that velocity. Okay, that worked that time. Because what I'm trying to do is I'm trying to get these couplets to be fairly well balanced as far as magnitude. So let's see, did that come out okay? 37 inbound, 30 outbound, that's pretty good. So we got about 60 knots of shear here. The diameter of that circulation is about 2 miles. So that's a fairly tight mesocyclone. That's going to be centered about right there. So we take that back to the velocity, to the reflectivity, and we can see that this updraft area here correlates pretty well with the location of the meso. So you're going to send your chasers out to this area in here and watch that. And does that tie in with the spectrum width? Well, I've kind of lost the... Oh, heck, we're up at 3.1. Let me screw that. Okay. Let's go back and put everything together again, because I think we got a new frame here. Things have moved on off. Oops, let me get rid of that. I'm still in cross-section mode, so let me switch that over to panning. Okay, so our circulation has broken up a little bit. Looks a little bit more outflowish, but let me go back to that last frame. Oh, you see, okay. I'm sorry about that. We were looking at a mid-level meso. For some reason I was thinking we were looking at the ground. I was kind of rushing through this. But yeah, you can see that mid-level meso. This is up at 6,000 feet. And that's significant because if we lose that at lower tilts, well, we're getting some new frames there. But if we lose the circulation, that tells us that the tornado risk is probably going to be somewhat minimal. So we're not going to have to worry about that too much. So mostly outflow here, looks like about 25 knots of outflow, stacking up to a mid-level meso, and that's pretty much the situation we got on that storm. There's the outflow. So this is kind of a balanced storm. It's hanging together, but I don't think we have a tornado risk on that at this time. Check what the other cells are doing real quick. Looks like another cell down the line, but you can see that the outflow has kind of pushed ahead of that. So the chance of tornadoes on this storm is probably going to be somewhat low. Follow the outflow boundary down here. Let's check out the spectrum width again so you can check that out. That kind of demarcates the outflow boundary. Then we pick up these cells here, and now these are outflowish. The outflow is gusted out about 3 to 5 miles ahead of these cells. So I'm not looking at much of a risk on these. Alright, well, we've messed around with the radar for about a good 5 or 10 minutes, so let's check out the forecast real quick. I'm going to pull up the precipitable water. Let me get that centered. Okay, starting out at 0 hours. Got quite a bit of moisture here around Florida and the Bahamas. That's going to be moving eastward with the tropical easterlies, and that's going to probably recirculate into Texas later this week. So keep an eye on that. We're going to move forward. See the first slug coming in on, let's see, this is going to be tomorrow night. So chances of rain are going to be going up east of I-35. There's that piece of moisture right there. It heads up into eastern Oklahoma, and then we have another slug heading in on Sunday. So our rain chances are going to go up. And now we're picking up that tropical disturbance. That's going to be coming in somewhere from Puerto Rico. I can't really make out the circulation here. I assume it's probably about right there. This is a... Actually, no, that's probably... Let's start from the beginning here. Okay, so starting out at 6 hours, there it is. Very, very kind of a weak circulation there over Puerto Rico. We're going to follow that westward. It's like that circulation kind of fizzles a bit. I can see it over Cuba on Friday evening. And it definitely does head into the Gulf. See there, picked up a little bit of a closed low. Very slow drift. And I think at this point it's about anybody's guess. It looks to me like maybe it actually recurved this back in the Atlantic. Yeah, see it right there. But this is a dynamical model, and this is 144 hours out, so this is definitely a gamble. You could probably place bets on the storm, and I really have no idea where it's headed to be honest. We'll see how it looks over the weekend and find out what's going to go on with that. And then looking at the dynamic pattern here. Jet well to the north, very meridional pattern. Get out to about 48 hours out. We're kind of hanging on with this long wave troughing in the western U.S. So that's going to keep the stronger flow pushed down into the central U.S. Have a new segment coming onto the west coast on Tuesday. But it looks like by next week we start getting this ridging in here, so that probably indicates our temperatures are going to start climbing up a little bit next week. So we're going to watch for that moisture, that increased fetch of moisture coming into Texas next week. On the other hand, we're going to be under this ridge too. So I would expect to be kind of hot, and hot with chances of precipitation next week. And then getting out to September 3rd, 4th. This is crystal ball territory, but we got a cutoff low off the California coast, strengthening flow across the central Rockies, and brings a trough down into Texas on the 7th. So, wow, that's pretty far out there. But September is almost here, less than a week. Anyway, we've run up to 12 minutes here. We've been running 12 minutes. This seems like this has been more like 20 or 25. Anyway, I appreciate you watching, and if you have any suggestions or feedback on this program, or if you want to see your city featured tomorrow or the next day, leave a comment. You can also go to weathergraphics.com and go to the contact page, and that's usually a better way to reach me. I sometimes miss the YouTube comments, but I definitely get all the email. All right, we will see you tomorrow, and I hope you had fun.